Hello all and welcome to this video on 17c. Today we're looking at differentiating x to the n when n is a negative integer. So we have previously looked at functions where if we had f of x is equal to x to the n, where n is equal to 0, 1, 2, 3, etc. And the rule was f dash of x is equal to, what we do is we multiply by the power, so we get n x, and then we just take 1 from the power, and we looked at that using first principles. Now what if n is negative? What happens? Well, let's go through this example looking at x to the negative 2. So let f be a function where it's all real values except for 0, because x to the negative 2 is the same as 1 on x to 2, so we can't have a denominator that's 0 because 0 to 0 doesn't work. So it's all real values apart from 0. Codomain is all real values. F of x equals x to the negative 2. Find f dash of x by first principles. So we substitute it in using our first principles equation here. And then that's first step. Second step, I'm just going to talk through the steps. I'm not going to write them out. Second step is we separate the function. Okay, separate the function through that bit there. Okay. And then third step is we write this in terms of positive indices. So instead of x to the negative 2, we move it down to the bottom, and that gives us x squared instead of a negative indice. And now we have a function that looks like this, which we can't do much unless we cross multiply. We cross multiply to make the numerators the same. You can see here we've cross multiplied, numerators are the same. Now that the numerators are the same, we can actually recombine the function. Now what's happened between here and here, it's the same thing, it's just now we have a function in terms of positive integers instead of negative, positive indices instead of negative indices. Now going down here, we take this bracket and we expand to there. And then this brings us all the way up to here, which all they're doing is expanding the bracket and carrying this negative sign through to each of the terms. Then that's just some cancellation. So cancel, cancel, takes us to this step. Now going to this step, we take out h as a common factor. Now that h is a common factor again, red, we cancel, cancel, gives us that. And now that we're here, we can actually start to solve the limit. So all it is going down to this step is let h equals 0. And we get that, and then it becomes this. Now what we can do, we have an x on the top and x to the 4 on the bottom. We can cancel, that turns 3. So we have negative 2 on x to the 3, which we can write as, get this, which is negative 2 multiplied by x to the power of negative 3. Now where did we start? We started here. F of x equals x to the negative 2, and we ended up with f dash of x equals negative 2x to the negative 3. What has happened? Well, just like up here, we have multiplied by the power. Negative 2 ends up in front multiplying, and our power has reduced by 1. Okay, it's still minus 1. We had negative 2, take away 1. That gives us negative 3. So this rule, this really handy rule for polynomial, still works when we have negative indices. So 17c is no different to 17d. Always multiply by the power and then subtract 1 from the power, and that'll give you the derivative of x to the n. So we can apply the shortcut. Our general rule for differentiation. Remember, the power must decrease by 1. So my suggestion, this a and b will be pretty straightforward, but c, you want to write it, you don't want to have indices in the denominator. Write it with indices in the numerator, and it'll be much easier. So y dash is going to be equal, we multiply by the power, the negative 3 up front, x, and then we're going to have negative 3 take away 1, so y dash is equal to negative 3x to the negative 4. And if you wanted to write it with positive indices, we could do that as something like that. Okay, but either of these two is fine. Okay, so this one is written as f of x, so that means I'm going to write as f dash of x is equal to, so multiply by the power for this first term, take 1 from the power, minus, okay, now multiply by the power, so negative 1, 2x, now negative 1, take 1 from the power, that goes to negative 2, and then the plus 3 just becomes plus 0, so x. So this turns into 3x squared plus 2x to the negative 2, which we can write as 3x squared plus 2 on x squared. Again, either of these two is fine. Okay. But still get in the habit of writing in positive powers. Now z, so I'm going to rewrite this first. I'm not going to take the derivative yet. Okay. With negative indices. I'm going to move x squared up here, which means the power becomes negative. Now I'm going to get z dash is equal to multiply by the power, take 1 from the power, plus multiply by the power, 3x, take 1 from the power, negative 2 minus 1. Okay, and this step here, I'm sure you can compress down, but I'm showing it for full working. And minus 6x to the negative 3, which can be the same as 4x cubed minus 6 on x cubed. Okay, so it's exactly the same. Multiply by the power, take 1 from the power. Okay, finding the gradient of the tangent. Okay, like in previous exercise, so 17b, we're often asked to find the gradient curve at a particular point. Nothing has changed. Just because we have a negative power, nothing has changed. Still finding f dash of x and then subbing in our point. Okay, so we have find the gradient of a tangent to the curve determined by the function where x is all real values apart from 0, where f of x equals 2x cubed minus 1 on x squared at the point. Okay, so we'll go f of x is equal to 2x cubed, and we're going to turn this, okay, we're going to get rid of this, we're going to move it up here, so minus x to negative 2. Okay. So f dash of x is equal to, goes on, multiply by the power, so we get 6x. 3 times 2 is 6, take 1 from the power is x squared, minus, okay, multiply by the power, negative 2x, negative 2, take away 1 is negative 3. We get f dash of x is equal to 6x squared plus 2x to negative 3 equal to 6x squared plus 2 on x cubed. Writing in terms of positive indices. Okay. Let x equal 1 because we're finding at the point 1, 1. It follows on f dash of 1 is equal to 6 by 1 squared minus 2 on 1 cubed is equal to 6 minus 2 on 1 is equal to 4. Therefore, gradient at 1, 1 is equal to 4. That's pretty straightforward. Really nice. This rule is, this shortcut I should say, is really handy. Now, example 3. For the curve f of x equals negative 2 on x to the power of 3, find the coordinates of the point at which the gradient has a tangent line is 96. Find when the gradient is 96. Okay, so we have f of x is equal to. So to clarify what this is asking, we're finding when f dash of x is equal to 96. That's what it is. When the gradient of the tangent is 96. F dash of x equal to 96. So we need to find f dash of x. Let it equal to 96 and then solve to get x, and then once we have that we can find our y value as well. So it's going to be negative 2x to negative 3 written in terms no denominator, so f dash of x is equal to negative 2 by negative 3x negative 4. So we get f dash of x is equal to 6x negative 4 is equal to 6 on x to the 4. So we let f dash of x equal 96, follows on 96 is equal to 6 on x to the 4, so we get 96x to the 4 equals 6, so x to the 4 is equal to 6 on 96, and I'm going to need a calculator. I think 96 is 36, so that's going to be the same as, take 6 as a common factor out, I get 1, and 10 is to 60, another 6, that's 16. What am I going to do from here? See, I should have checked these slides before I started the video, so I knew how to do this. I can get my brain to think. Taking the 4th root. Come up here. Let's just start writing some stuff. So x is going to be equal to the 4th root of 6 on 26. I've done all this right. Yep. The 4th root of 6 is not nice. What am I missing? Well, I'm an absolute bozo. You can tell it's 7:48 a.m. on a Sunday morning because I'm an absolute clown. Let's take this. Take out the common factor of 6. X to the 4 gives us 1 on 16. X is equal to the 4th root of 1 on 16. X is equal to, that is going to be 1 on 4th root of 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So x is going to be half. Okay. Therefore, we need to find f of half is equal to negative 2 on 3 is equal to negative 2 on, that's going to be 1 over 2 times 2 is 4, times 2 is 8, so that's the same as negative 2 times by 8 on 1 is equal to negative 16. So the point when the gradient is equal to 96 is half neg 16. I was way overthinking that problem. Okay, that is that. Okay. At times you'll be given now, and this is starting to introduce you, instead of just doing numerical solutions like we just did on this page, you'll be given show that questions. Okay. So in methods year 11, 12, you get show that questions. So you sort of, it's almost like a proof, not quite to the full extent, but it's important to know how to approach these and show correct steps. So an example, show that the derivative of the function all real values where x is everything apart from 0, where f of x is x to the -3 is always negative. So f of x is equal to x to the -3. Show that f dash of x will always be negative. Okay. Well, that's the same as, okay, we'll leave it because we need to find the derivative. So we firstly find the derivative, looks like this, which looks like we can rearrange to write in terms of a positive indice, which will help in these problems. Okay, as the variable x has a power of 4, see here, any value that we put in, doesn't matter if x is positive or negative, it will become positive, because anything negative to the power of 4 will equal positive. Anything positive to the power of 4 will equal positive. Okay. Given that the numerator contains a negative solution, the final solution will always be negative, because we'll always end up with -3 on something that is positive. Therefore, our answer will always be negative. That's how we do this. So you'll do some form of numerical work. Okay. Numerical work, and then you'll have some worded description doing your proof. So let's have a go at this one. Show the derivative of the function f between 0 and infinity, giving domain of all real values. Fx equals 3x to the power of 4 will always be positive. Okay. So f of x is equal to 3x to the 4. So f dash of x will be equal to 12x to the cubed. So multiply by the power, take 1 from the power. And then here, this is the key, okay? All x is positive, okay? In this situation, okay? Since all x is positive, the cube of x will be positive sign, PE, short for positive. Okay, since all x is positive, the cube of x will be positive, and multiplied by 12 will remain positive. Therefore, okay, f dash of x is always positive for given domain. Okay, so most of this, the numerical bit, is pretty easy. You then need to look at the value and the conditions importantly and see how they work together to provide the show that. That is it for 17C. Hope you have a good day. If you have any questions, stick them on Google Classroom or when I'm in class. Thank you.